Welcome to the STEAM Fair. I'm Mayar Mahmoud from grade 8 and my project is about the nature of light. What is light? Is it a wave or a particle? Light is very mysterious. For that, I chose my project to be about the nature of light, to define it and whether it's a particle or a wave with some of its properties and what great scientists used to think about it. Firstly, on 1700, Newton, of course we all know him, stated that light is a particle, not a wave, as it reaches us from the sun without a medium. If it was a wave, it wouldn't have traveled without a medium. After that, on 1801, another scientist called Young wanted to make an experiment to test this theory. His experiment is called Young's double slit, and from that time until now, it's still studied, and it's said that it's one of the greatest experiments in physics. His experiment is to making two holes. These holes will act as new sources, and new sources of light. Each source will scatter light, and the scattering light will diffract or will interfere with each other, performing an interference pattern. If you want to see it, here is it. Okay. To be clearer, we have to use the lenses, but of course, it's definitely different than a normal laser. After that, in 1818, another scientist called Fresnel wanted to make another experiment. His experiment is about refraction, and I'm going to do it with you now. Here we have two arrows. It's directed to the left, to the right. If we put it like this, you can see that its direction is changed from the left to right. This is because when light rays are passed through the water, it's bended one time because of difference in speed, and then bended another time. These two bendings let us see the shape 180 degrees flipped. Lastly, sources of light as the sun transmit light of all directions, oscillate light of all directions. This can sometimes be a problem, as for people who have a problem in sightseeing, they don't want to encounter much radiation. Here comes the polarizers into play. Polarizers are filters that allow only one direction of light to pass through and blocks the other. If I put here a laser, you can see it has a maximum intensity. But if I put it through a polarizer, you can observe that the intensity has changed. And if I put it through two polarizers, the intensity is zero. Because the light transmitted in one direction, this polarizer have a different direction. So it won't appear like this without a polarizer, here with one polarizer, and here with two polarizers. In conclusion, light has a dual nature. It sometimes acts as a wave and sometimes acts as a particle. And this is what Einstein said in 1813, and he took a Nobel Prize for a related idea. And light is an electromagnetic radiation that can be detected by the human eye. In the end, this was a very small summary of a very wide topic. And thank you for your attention. That was my project.
Good morning everyone and welcome to our project area. As you can see on the screen, our project is talking about the laser light maze project. As an introduction, today Operation Einstein will be featuring another exciting experiment from our idea bank, which is called the laser light maze. What is a light maze? Light maze is an enveloping light experience that is full of light and colors. And for the purpose of the light maze is that we use it to direct the laser through a series of mind-challenging mazes, and we have to light up a target, and it's very fun. Everyone in your family will want to turn.
Now, as she said, we have this target to light up using the laser. This laser we have right here. Now, for the tokens to help us, we have the satellite mirrors. Is to help us reflect the light. And another token is we have the beam splitter. It will split the light into two ways, directly and in 90 degrees. And the last token is we have the space rock blocker. It will block the path of the laser.
Now we have reached the scientific method. We were going to be talking about how matter works. The first thing we have to know, which is light travels as a straight line, and it can be illustrated as arrows with direction from a light source. For example, this flashlight. When light reaches an opaque object, shadows are formed. This is because the light travels in a straight line. For example, the laser is cannot pass through this cardboard wall. Yeah. The next thing we have to talk about, which is the reflection. The coming ray, comes to the mirror surface, which is called the incident ray. When it will be bounced off or reflected, this is going to be called the reflected ray. The point of incidence, it is the point where the light ray hits the surface of the mirror. And the normal, it is the line that is perpendicular to the surface of the mirror. In addition, we have the angle of incidence equals the angle of reflection. Yes? So I equals R.
Okay, now we have two types of reflections. We have the first type is specular reflection, which is the reflection caused by a smooth surface. A smooth surface here, for example, is the mirror we have. And another type of reflection is diffuse reflection, which is caused by the reflections of rough surfaces, just like aluminium foil, for example. So the reflection will scatter all of the place in many different directions.
Next thing we will be talking about, which is the procedure. The two things we're going to be talking about, which is the setups and the steps to play. First of all, we have to select a challenge card, for example like this one, and we have to place it under the game grid. Then we have to place each token on the game grid with the same location and orientation. There you go. For example, it's telling us to put one rocket target here with the same location and orientation. Then it's telling us also to add some tokens from add to grid, so we have to add them to the game grid. So we need to add one satellite emitter in order to light this rocket target, just like this. Number 4, we have to identify the rocket target symbol and which side have to glow or ignite. And if we have 2 rocket targets, then we have to light them both up in order for us to win. Number 5, we have to turn the red knob on in order to activate the laser beam. Next thing is the steps to play. We have to take a few minutes to know the function of each token. So the best way to understand that, so we have to place each one in front of the laser beam, just like this. And Sarah already explained it in the token guide. Number 2, we begin placing the tokens from add to grid as we mentioned before. And it also includes some rules, we have to know them.
Now the steps to play is, we select a challenge card, one of these challenge cards, and we have tokens in the game in the challenge card grid, and we have add to grid in the challenge card, tokens that we will add. So when you add the tokens that are in the challenge grid, we will not move them at all. This is a part of the challenge. But the tokens that are in the add to grid, we can move them however we like to light up this target.
As we light up the rocket target, then we win. To wrap up everything, we have to know that lights and mirror may make it feel like magic, but it's really science and a good dose of brain power that is needed to direct the laser beam through a series of mind-challenging mazes. We sincerely appreciate your attention today and thank you for listening.